Test review, and straight into it. Question 1. A bird sits on a uniform rod suspended by vertical wires P and Q. The rod has a weight W and is 15.0 centimeters long. The weight of the bird is 2W and acts at a distance x from P. What is the value of x when the tension in P is half the tension in Q? So, it's a moments question. So let's take moments about a point through which an unknown force acts. Let's take P. So we have got 2W times x going clockwise, and we would have W, the weight of the rod, acting at 7.5 centimeters because it is a uniform rod, so the center of mass will be in the middle, so W will act here. So there's our clockwise, and that will equal Q times 15. So what else do we know? We know that P is going to be half of Q. So we also can say that because it's an equilibrium, the sum of the forces is 0. So if we apply our second condition for equilibrium, we can say that 2W plus W equals P plus Q. So that's 3W equals P plus Q. So if P is a half Q, then 3W equals 1.5 Q, so Q equals 2W. So then we can stick that back in there. We now have 2WX plus W times 7.5 equals 15 times 2W. And the W's will cancel, of course, which gives us X to be 11.25, X is 11.3, and that is the answer C. So that's question 1. And you might reasonably say that's an awful lot of work for 1 mark. Can't argue with you, but there it is. So, question 2 then. They're not all that difficult. Question 2. The diagram shows a uniform meter ruler of weight 1.5 newtons, pivoted 15 centimeters from one end for use as a simple balance. A scale pan of weight 0.5 newtons is placed at the end of the ruler, and an object of unknown weight is placed in the pan. The ruler is moved to a steady horizontal position where a weight of 2.5 newtons is added at a distance of 60 centimeters from the pivot as shown. What is the weight of the object? Well then, let's take moments about the pivot. I'm doing that because I'm going to have a reaction here and I don't know what it is. So if we take moments about that point, then we can ignore the reaction. So we have our unknown weight plus 0.5 at a distance of 15 centimeters going anti-clockwise, and we have our 1.5, the weight of the ruler, and that's going to be 35 centimeters from the pivot because it's going to be at the 50 centimeter mark. So if that's 15, 50 is going to be 35 from here. Plus our 2.5 times 60. And from that we can get our W. And W then gives you 13 newtons. Which is C. Question 3 then. A light, uniform, rigid bar is pivoted at its centre. Forces act on the bar at its ends and at the centre. Which diagram shows the bar in equilibrium? Well, let's apply our sum of forces. That seems to be the quickest, easiest one to apply. And we've got 2 and 8 down, and we've got 4, 4, 2 up. So A is good. We've got 8 down and 8 up. Sorry, 10 up, so B is no good. We've got 2, 4, 8 down, 4, 6, 8 down, so C is good. And we've got 8 to 12 and 8, so D is no good. So we're now down to A and C. Only A and C could be in equilibrium, and that's down to moments. So let's apply our principle of moments. And if we look here, this is going to be 2 newtons clockwise, acting at the full distance if we take moments about this end, and you're going to have 8 newtons acting at half the distance. So sorry, 4 newtons acting at half the distance. So 2 newtons acting clockwise at the full distance, 4 newtons acting anti-clockwise at half the distance. A is your answer. And you can check C as well, but we've verified that A is in equilibrium, and there is only one. If you check C, you'll find that it isn't. So, question 4. A car bonnet represented by QP of mass 12 kilos is pivoted at P. Its weight acts at G, where OG equals GP equals 1 metre. So this is halfway between the two. What force F acting perpendicular to QP as shown is required to hold the bonnet at 30 degrees to the horizontal? Well, it will be the perpendicular component of the weight which is causing the anti-clockwise moment. So F times 2 will equal mg cos 30 times 1, which gives F to be, given that we know the mass is 12 and G is 9.8, that gives 51 newtons, which is B. Question 5 then. The diagram shows a uniform door hanging from 2 hinges 2.5 meters apart. We've got 200 newtons acting in the middle of the door. It's a uniform door, so the 200 is bang in the middle, will be 0.75 meters from here, and bang in the middle of the side as well. Not that that's important, but it is. The moment of the couple that the hinges exert on the door is, well, we have the moment of the 200 newtons about each hinge. Because it's a uniform door, the hinges will bear the same force, and so the same moment at each hinge, and therefore we can work out the couple, which is the force times the perpendicular distance between their lines of action, of course. So, question 5. Let's take moments about the bottom hinge. Doesn't matter whether we do the top or the bottom. So we've got 200 and the perpendicular distance of its line of action from the bottom hinge is 0.75. So we have got 200 newtons times 0.75, and that has to equal the force due to the hinge at the top times 2.5, which gives us the force at the hinge at the top to be 60 newtons, and the couple then is the size of the force times the perpendicular distance between the hinges, which will give you 150 newton meters. So the answer is A. Question 6. A uniform square block is sliding with uniform speed along a rough surface as shown in the diagram. The force used to move the block is 200 newtons. The moment of the frictional force acting on the block by the centre of gravity of the block is. So, the moment will be 200, the size of the force, times the perpendicular distance of its line of action from the pivot, which we're taking to be the centre of mass, centre of gravity, which is 0.75 because it is a uniform block. And so, nice and straightforward, it is 150 newton meters acting clockwise. It's clockwise because, of course, the block's moving this way and friction opposes motion, so friction's going this way, so it tends to turn it that way. Okay. Question 7. This one's a bit easier. Which of the following is scalar? Well, energy isn't, momentum, energy is, momentum isn't, force isn't, acceleration isn't. So kinetic energy is the answer, it's A. Question 8, which is correct for the quantities. Well, impulse, that is force times time. So that has to be a vector, and force is a vector. So the answer has to be D. Oh, that's an 8, sorry. Question 9. As I said, they're not all as difficult as the first few. System shown, light rigid beam, pivoted at X, held in position by a string which is fixed at Y. The beam carries a load of 200 newtons. The load is moved towards X. Which one of the following statements is correct? Well, the moment due to the string is going to have to balance the moment due to the 200 newtons, the moment due to the tension in the string. So as this moves in, the tension is going to get less, as you would expect. So A is wrong. The compression force in the beam increases. The force pulling in on the beam, so the horizontal component of the tension increases. Well, there isn't any reason for the horizontal component of the tension to increase. It will change as a consequence of, so the tension will increase, but the vertical component is what has to change as the mass moves around. So that's not true. The moment of the load about x increases. Well, clearly not. If the 200 is moving in, that's nonsense. The magnitude of the vertical component of the reaction at x increases. Well, that is the only option we have remaining. So it has to be D. Question 10. A car wheel nut can be loosened by applying a force of 200 newtons on the end of a bar of length 0.8 meters, as in X. A car mechanic is capable of applying forces of 500 newtons simultaneously in opposite directions on the end of a wheel wrench, as in Y. What is the minimum length L of the wrench which would be needed for him to loosen the nut? So the first thing we have to do is to work out the moment required to loosen the nut. So the moment required is 200 times 0.8. So there's 160 Newton meters. So 160 Newton meters is the couple that will be supplied, which is equal to 500 times L. So L then is 160 divided by 500, which gives us the answer of B. Question 11. The rectangular objects A, B, C, D are each 2 by 1 centimeters. Which one of the bodies is in equilibrium? Well, let's start with A. If we do the sum of forces, well, we've got 10 up and 10 down, so A could be. B, well, you've got a 3, 4, 5 triangle there. You don't have a 3, 4, 5 triangle, sorry. But the triangle works. You have 2, 4, 4.5. It's a closed triangle. If you do the numbers, 4 squared plus 2 squared, square rooted will give you 4.5. So that the forces are in equilibrium. C and D, no, that's not right. That looks similar, but because the 4.5 is going the other way, then this is not a closed polygon and closed triangle. And clearly, if you took the vertical components, in fact, no. You've got 2 vertical components there adding together and with the 4. So D is not in equilibrium either. So, oops. We have established that A and B could be and if we look then at our second criterion, that we have to have no moment about any point. Well, if we picked this point, say, there clearly is a moment, because the 10 at 2 centimeters and the 6 at 1 is not going to work. They're not going to cancel. But all of the forces run through this point, so there is no moment about this point. So the answer is B. Question 12. A pivoted meter ruler is supported in equilibrium horizontally by a thread inclined at 30 degrees to the vertical. Three forces act on the ruler: weight, tension, and reaction at the pivot. Which of these three diagrams drawn to scale represents the magnitudes and directions of these three forces? Well, if it's going to be an equilibrium, then your tension and your weight are going to be balanced by your reaction, right? So given that we know the tension is up and to the right and the weight is vertically down, then the reaction must be going to the left. So let's have a look. What options do we have? Well, we have this one going to the left and we have this one going to the left. So the difference between these is the relative sizes. Triangles are similar, not in a mathematical sense, but they are the forces are all going in the right directions, is what I mean. So we need a way of deciding whether T is bigger or smaller than W, right? So let's have a look. In other words, is W the hypotenuse or is T the hypotenuse? Well, if you think about this, T cos 30 is going to be balancing our W potentially, right? So you would say T cos 30 times this distance equals W times this distance. That's going to be our moments. So T cos 30 is going to make T smaller. And you'd expect that anyway. So W must be our hypotenuse. And therefore our answer is B. (13) A non-uniform sign, 0.8 meters long, has a weight of 18 newtons. It is suspended from two vertical springs P and Q. The springs obey Hooke's law and the spring constant of each spring is 240 newton meters. Now, I'm relying on your recall of Hooke's law from GCSE here, but it's possibly the simplest law you ever came across. So, question 13. Let's take moments about a point through which an unknown force acts. P. Could be Q. But we want the value at Q, so it makes sense to take it around P. So we've got 18 times 0.65, and that's going to be 240. It's going to be kx, F equals kx, remember? 240x times 0.8, which gives us x to be 0.061, and that is D. Another easier question, at least I think it's easier, I imagine you agree. Which line A to D in the table correctly shows whether the moment, momentum, are scalar or vectors? Well, again, you should remember momentum from GCSE as a vector. And moment is force times distance. So your moment is also a vector, and the only correct option there then is D. Question 15. Two forces, 6 and 10 newtons, act at a point. Which of the following could not be the magnitude of the result? So, I'd be thinking, what are my extreme values? Well, the 6 and the 10 could be acting in the same direction, along the same line. That's as big as it gets, 16. So definitely 16 is a possibility. And the smallest value of the force then would be 6 minus 10. So it could be 4 newtons. Cannot get any smaller than 4, therefore D cannot be true. You could get every value between 4 newtons and 16 newtons, but you can't get 3. So 15 the answer has to be D. 16. A firework is fired vertically up into the air, which quantity relating to its motion is never zero. Well, it's on Earth, presumably, and so gravity always acts. Its velocity is changing and will get to zero. Its momentum will get to zero because its velocity gets to zero. Its KE will get to zero because its velocity gets to zero. The only one that doesn't ever hit zero is the acceleration. It's always minus 9.8 meters per second squared because it's going up but slowing down. There it is. Question 17, a bit of playing about with units. So, which of the following is not a unit of power? Well, we've got newtons in there, so I'm thinking power is work divided by time, which is force times distance over time, which is Newton meters over seconds, Newton meters, seconds to minus 1. Well, yes, that is. I've got kilograms meters squared per second cubed. Well, that makes me think of F equals ma, because that's kilograms meters per second squared. So force times distance over time would be kilograms meters per second squared over seconds, kilograms meters seconds to the minus 3. Well, look, we haven't got meters squared. Are we right? Kilograms meters per second squared. That's right. Seconds. So that is correct. So that is not. Oh, I'm sorry. I didn't multiply by meters, did I? So that is right. So on to the next one, joules per second. Well, power is energy over time. That is joules per second, so that's right. So the only one that can be wrong is D, but if we look at D, B and D are very similar. They can't both be right. We've established that B is right, so the answer must be D. Question 18. Three coplanar forces, F1, F2, F3, act on a point. Which combination of forces can never produce a resultant force of 0? Well, here you have a 3, 4, 5 triangle. That will form a closed triangle, and therefore that one can give you a resultant of 0. B, well, you've got 3 eighths equilateral triangle. So again, that can form a closed triangle and therefore can give you a resultant of 0. Here we've got 2 10s and a 2. That's an isosceles triangle, so that works. 3, 6, 10, you're not going to get a closed triangle with that. Apart from the fact you've just got to this as the last option, you can't get a closed triangle with that. So 18, the answer must be D. So this is relying on your knowledge that a closed polygon is what you need for 0 resultant. Question 19. We have jogs at 2 meters per second for 30 seconds, so she's covered 60 meters. Turns around and returns to her starting point, another 60 meters, 120 meters in 20 seconds. Sorry, 50 seconds. So her speed, her average speed, 120 over 50, 2.4 meters per second. So her average speed, 2.4. Now her average velocity, well, her displacement when she's finished is 0, so her average velocity is 0. So the answer is A. '20. Aircraft flying due north through still air with a speed v. The the aircraft enters a region where the wind is blowing with a speed u from a direction which makes an angle theta with the south, with due south. What is the time taken? Well, the time obviously is distance divided by speed. That's what you have in all of these. So the question is, what is the speed or the velocity? So you've got v minus the vertical component of u, which should be u cos theta. So v minus u cos theta. On the bottom line, the answer is A. 21. Units can be expressed in terms of fundamental base units in the SI system. In which line on the table are the fundamental units correctly matched to the physical quantity? Charge. Well, current, of course, is coulombs per second. So coulombs would be amps seconds. So that's not right because that's amps per second. Power, kilograms meter squared per second to the minus 3. Well, we've come across this before. So you might look back and say, well, I know B is right. But you would work it out just like I did before. And you'd find that B is right. Potential difference. Well, let's look at this then. Potential difference, joules per coulomb. Joules would be Newton meters, 1 joule being the work done by 1 Newton moving its point of application through a distance of 1 meter. And newtons are kilograms meters per second squared from F equals ma. So we've got kilograms meters per second squared times meters, kilograms meters squared per second squared. That's our joules per coulomb. Well, a coulomb is an amp second. So it's per amp per second. So that's no good, because you can see that those are different. Different seconds to the minus 3 and seconds to the power of 1 there. Energy, well, force times distance would do that. So we've got kilograms meters per second squared times meters. Kilograms meters squared per second squared. Well, again, not right. But we knew the answer was B, but obviously if we hadn't had that previous question, we'd have had to work it out. So that's why the others are not right. 22 then. Nearly there. A deep space probe travelling forward at constant speed is briefly acted on by a force at right angles to its motion. What effect does this force have? Forward speed increases? No. It's at right angles to the direction of motion, so that's not going to be true. Forward speed decreases, again, rubbish, because force at right angles to that direction will have no effect in that direction. The forward speed is unchanged, yes. Sideways speed increases, yes. So the only possible answer is C. The rest are clearly nonsense. 23. Coplanar forces 5, 4, 3. 3, 4, 5 triangle again, so 0 is definitely a possibility. 4 newtons, well, you could have anything from 5 and 4 is 9 and 3 is 12. You could have 12, the minimum possible. 5 minus 4 minus 3. So you could have 2 newtons, but your maximum you found was 12, so you can't have D. That's the one you cannot have. Which of the following could not be a unit of force? Well, again, we're pulling back to GCSE with Tesla here, from F equals BIL, if you remember. So the Tesla is the force on a 1 meter long conductor carrying a current of 1 amp at right angles to a field. So that's Tesla. and we're multiplying by amps and meters. So that cancels with that, that cancels with that, so that works. Watts per second squared. Well, let's think about this now. Watts, force times distance over time. And then over time again, twice. So are we going to manage to cancel, because we just want the newtons, right? We're going to cancel distance with seconds cubed? Absolutely not. So that's not going to work. So we know B doesn't work. We could stop there. Kilograms meters per second squared for force, well, that is MA basically, kilograms meters per second squared. Joules per meter, well, a joule is a newton meter, remember? So newtons would be joules per meter. And finally then, 25, which row correctly states whether momentum, mass and velocity are scalars or vectors? Vector, scalar, vector. D. So there it is. 25 multiple choice questions, some of which are quite challenging, some of which are not. A good mix, perhaps.